Greetings, everyone. This is Jeff Wilkerson, Professor of Physics at Luther College, bringing you the next in our series of what to look for in the night sky. This time we're talking about August 1st, 2022. We've transitioned to late summer. Here in northeast Iowa, we can see it, and the flowers around and the plants, the wild parsnip that's so dastardly is starting to die back in some places, getting brown, and the roadside flowers have turned to chicory, for example, sort of a blue-purple chicory lining the roadsides. We see a lot of yellow flowers starting to bloom, smooth oxeye, a black-eyed Susan among those, sweet coneflower. So we see these yellow flowers starting to take over the purple flowers, particularly the chicory, starting to appear, and that tells us late summer has arrived. We're starting to transition. We even think about fall a little bit. We see a few leaves here and there starting to turn red. So we're making this transition. We see it in the sky too. Virgo, a real marker of the spring sky, is now getting to be low on the western horizon as it starts to get dark. Our markers of the summer sky, the zodiacal constellations of summer, Sagittarius and Scorpius, high in the sky as it gets dark now. Look straight south as it gets dark, and you will see these constellations. Scorpius is already past the meridian. It's already on the west side of the meridian, thinking about moving towards setting when it gets dark here. And later at night, then what happens once you get past midnight, you start to see the stars that we associate most commonly, that I associate most commonly with fall, the great square of Pegasus, Andromeda, Cassiopeia, and Perseus rising into the sky. That tells us fall is just right around the corner here. So we're making it through another year. Hope it's been a good one for you, and I hope you've had some clear skies. So let's take advantage of some of these things we're talking about here. This week, let's start the week, August 2nd, Tuesday evening, August 2nd. We will be able to find the moon very near Porrima in Virgo. We've talked about this star before. This is a great star, the Gamma star in Virgo. Virgo looks kind of like a martini glass, I've said, with spica down at the base like this. There's your Y shape with the base down this direction, and Porrima marks the bottom of the cup of this martini glass, the open part of the martini glass. It's a double star, a binary star. It's a great binary star because I know. Some of you who are watching this think that 2000s, the 2000s, 2005 to 2010 was a long time ago. But some of us don't think that was very long ago. And this is a binary star that has an orbital period of 175 years. And it goes from fairly wide open, 6 or 7 arc seconds, so that you can see it relatively easily with a small telescope, to right on top of one another. You see this elliptical orbit as these two stars orbit around each other like this. The two stars can be very close together or pretty widely separated. Just 15 years ago, these stars were right on top of each other, and you could not see them as a double star at all. Now, the separation is something on the order of 3 arc seconds, which is relatively easy to split in a small telescope. So you can see these as two stars once again. In 15 short years, this has opened up. So this is worth going out and checking out this star as a double star. I know we've talked about it before. We talk about the star a lot. And the reason we talk about this star a lot is when you picture your geometry, we like to think about our geometry here. You picture the geometry. Here's the sun. Here's the Earth orbiting around the sun. All the other planets orbit in a relatively flat plane. We call that the ecliptic, the plane of the solar system. So that when we look out at the planets, we see a path of stars that these planets and our moon are always near, and the sun are near. And Porrima is one of these stars that a lot of things pass by. So kind of picture yourself standing here. I'm sorry, singing a Beatles song. Picture yourself in a boat on a river, but that's a different thing. Picture yourself standing here, looking out at these planets as we pass them, and we see Mars and Jupiter and Saturn and our moon going around us, and what we see beyond where we're looking in that disk, where we see beyond, and we see Porrima right there. So it comes up a lot because things scoot past there. And on the 2nd of August, the moon will be scooting past there. It will be, the moon will actually at times occult. It will actually pass right over the top of Porrima, and it will do so this time for observers in Central and South America, although I believe it'll probably happen during daylight hours. You probably, if you're watching this video from South America, thanks for checking in. But you probably won't be able to see this because this is going to happen in daylight. For me, I'll be waiting for it to get dark on August 2nd. And it'll get dark, the moon will be starting to pull away, but the moon will still be within a degree or so of this relatively bright star. So it's going to just be a spectacular pairing. The moon will be about 25% full and waxing out. And so look for that evening, as soon as it gets dark, wherever you are on August 2nd, as soon as it gets dark, look to see where the moon is and see if you can find Porrima right there beside it. It should be great. Okay, you should get a really, really, really fantastic view of that pairing of the moon. By 5 days later on August 7th, just after dark, the moon will be about 70% full. So we're going from about 25% full to about 70% full, and it'll be very near the bright star Antares in Scorpius. Okay, so we have Scorpius right here. It'll be about 5 degrees, about half of your fist at arm's length. So another nice pairing with a bigger, brighter moon. So you can watch the moon slide from Virgo to Scorpius and think about this. Okay, here we are as we've made this. We've already talked about the fact we've made this transition to late summer, and we see this moving along here. Sagittarius sits right here above the tail of Scorpius. We talked about Sagittarius last week. I'm sure you remember it because you remember everything I ever tell you, of course. And we said we would come back. There's so many objects in Sagittarius. We'd come back and look at it. Maybe not this week, and we were right, not this week. So maybe next week we'll come back and talk about the teapot asterism and Sagittarius and the clusters and nebulae and stuff that we can see in there that we didn't get a chance to talk about last week. Maybe we'll do that again next week. Now, any night this week, if you stay up past midnight or you get up early or whatever it is you do, you can see the constellation, we said, you can see Pegasus and Andromeda and Cassiopeia and Perseus climbing into the morning sky, coming up after midnight. You'll hear about this week because we're at the time for the Perseid meteor shower. You probably, by the time this video posts, you'll probably be hearing something about the Perseid meteor shower. Maybe you already have. It's one of our most predictable, most reliable meteor showers with lots of good meteors, 80 or 90 meteors per hour, 1 per minute. You know, you go outside under dark skies and you can see 1 per minute. And it always peaks around August 11th, August 12th, or August 13th. Our problem this year is that August 11th and 12th, the full moon, this moon that's getting fuller and fuller and fuller, has made it to 70% full by August 7th. You see the direction it's headed, right? August 2nd, 25% full. August 7th, 70% full. August 11th and 12th, 100% full. A big, bright, full moon washing out those meteors. So not a great time to go out and observe meteors. But this week, go ahead and give it a try. By the time the radiant, so remember more geometry, as we orbit through, when we have annual meteor showers, they come from us orbiting through the debris left by a comet. And we can hit that debris at different angles and in different places. Think of that debris as a big tube of material. So you've got this big tube of material, dust, that's been boiled off, and we hit that tube of material and we pass through it, and we get these streaks of stuff burning up in our atmosphere. These are our Perseid meteors. And we call them Perseids because at that point we're orbiting through this dust cloud, and as we orbit through this dust cloud, we hit the material, and it all enters our atmosphere at the same spot, and so the meteors all look like they're coming from the same spot in the sky. That spot is called the radiant. You may see the meteor way over here, but if you trace it back, it would have looked like it came from that radiant up here in Perseus. Okay, so now I've messed up this picture on the board. Perseus looks like this sort of J of stars and a couple of strands of legs of stars, and we've talked about that before up here. Cassiopeia looks like a W with the left-hand side lying down weakly. And so anyway, we're hitting, the radiant is in Perseus. I don't actually remember exactly where it is. I drew it too high. It's down here someplace. So the radiant is in Perseus, and we see that's where we can trace the meteors back to look like they're coming from. The thing about it is, remember, big tube of material. How many times can I do this in one video? Big tube of material, big tube of material. So we've got this big tunnel of material that we're sliding through, we're crashing through, And so it takes us a while to get through there. And there are denser parts and there are less dense parts. We hit the dense part and we get the peak of the meteor shower, lots of meteors. That's what happens on August 11th and 12th. But I'll tell you what, folks, we're already in that too. We're already passing through that material. And you can go out this week before the moon has gotten to be so full and so glaring. And in fact, when it's waxing like this, when the moon is in its waxing phases, going from 25% to 70% full, that means it sets before sunrise. And so it's setting now by the time you get after midnight, especially early in the week. By the time you get after midnight, the moon will have set. It will be out of your way, and you can look for these meteors. And what's going to happen is, I think you'll be able to probably see something on the order of 6, 8, 10 meteors per hour, which means every 10 or every 6 to 10 minutes, 5 to 10 minutes, let's say. Every 5 to 10 minutes, you'll be able to see a meteor, which isn't bad. This time of year, it's warm for those of us in the northern hemisphere, and so you can go out and you can spend a little bit of time outside wandering around in a nice warm overnight pre-dawn kind of evening, and you can have a chance to say, spend an hour outside and see 6 or 8 really good meteors. And so that's probably worth doing. It's probably a good thing to do. If you make a graph of what astronomers would call zenith hourly rate, ZHR, the rate of meteors as a function of time, it's going to look something like this. And there's your peak around August 11th and 12th, where this number might get up to be 60, 80, 90, 100. And this level in here is somewhere on the order of 10, 8 or 10 per hour that you're seeing, or something along those lines, maybe 12. So that's where we are. We're in here right now ahead of that peak, but when we get to this peak, we're going to be obscured by moonlight. So I'd say go out this week and try to see some Perseus. It's worth the time to do. It's going to be great, and spend a little bit of time doing that. So that's what we got for you. We got the moon passing very near a couple of bright stars, and we've got Perseus and Cassiopeia here. So Cassiopeia looks like this W. Perseus looks like this J, sweep of stars like this. Right, if you just extend that J and point at the back of Cassiopeia, I'm sure we've talked about it before. Right there is something called the double cluster. While you're out there watching the Perseid meteor shower, thinking about Perseus, go ahead and take your small telescope or your binoculars out. These are great binoculars. 2 fuzzy patches of stars that are open star clusters, very big, rich open star clusters. So lots of stars in these open clusters. Remember, open clusters are smaller. They contain fewer stars than globular clusters, and they live right in the plane of our galaxy. Last week we talked about globular clusters some. Here's a couple of open star clusters for you to see. If you have a small telescope, particularly a really small telescope works for this even, so that you can actually see these clusters. You can slide from one to the other, just a rich glittering of stars. But they show up really well in binoculars, and you can see them without any optical aid. You don't need binoculars or a telescope to look for 2 fuzzy patches lying right next to each other, sort of a fuzzy patches right on top of each other, more or less halfway between the J of Perseus and the back of Cassiopeia, the side of the W that's lying down a little bit weakly. So now that's what we got for you this week. Think about all of this stuff. I hope you have a good week, everybody. I hope you have some clear skies, have a chance to get out and observe some of these things. And as always, thanks for watching.